We are going to be talking about derivatives. You know, many people don't actually know what derivative is. The only thing they know is if you give them a function f of x and then you ask them to find the derivative of the function, they only differentiate the function and then maybe if it is x squared, they take the derivative, the first derivative, 2x, the second derivative, 2. But they don't actually know what derivative or differentiation is all about. So in this video, we are going to be looking the concept of differentiation from the graph of a function to the limit. So we are going to be covering all the concepts about differentiation, majorly from the first principle. So in this video, we are not actually differentiating much function. We just want to know what makes up differentiation. Why are we differentiating? So let's start. So to start, let's assume we have this plane, the x and y plane. And of course, this is y and this is x. And we know that this y is the function of x. We always know that the y is the function of x. Now, suppose we have x or suppose we have y equal to the function of x and this is equal to x. Now, you see that we just have, from here, we just have y equal to x. If we are to plot this function, if we are to plot this function on this graph, you see that if we put a value for x, as x increases, y will also increase. Assuming we put a value for x, say 2, y also will be 2. If x is 3, y will be 3. If x is 5, y also will be 5. So you see that an increase in x gives us a corresponding increase in y. So both x and y here will increase equally. So if you see, if you are to plot this function here, this can be your origin 0. If this is 1, this will be 1. If this is 2, this will be 2. If this is 3, this will be 3. And if you should trace those points, we are going to have a straight line graph. And that graph will pass through the origin. You have a straight line graph. Because once you have 1 here, y will be 1. So you mark this point. If you have 2 here, y will be 2. You mark this point. So if you keep on doing it to maybe infinity, you just have an infinitesimal line that passes through the origin. Now, where differentiation comes in now is, assuming we want to find the slope of this graph. If we want to find the slope of this graph, we can say, okay, let's mark any point here and find the change in y, and also find the change in x. We are going to have something like this. Okay, and you see that since both x and y increases equally, since both x and y increases equally, if the change in y is equal to 4, if the change in y is equal to 4, if the change in y is equal to 4, the change in x also must be equal to 4. Why? Because both x and y increases equally. Y equal to x. If x is 5, y also will be 5. If x is 7, y also will be 7. So now, from this now, what is the slope of this line? We remember that the slope is equal to the change in y over the change in x. And if you observe now, if change in y is 4, change in x will also be 4. So it means that the slope of this line will be equal to 4 over 4, which is equal to 1. So the slope of this straight line is equal to 1. Now, the same thing, for those of us that know how to differentiate, if you should differentiate this, you have dy dx equal to 1. Okay, but let's wait there first and continue. Now that we have know that the slope of this function is equal to 1, Now, why do we have dy dx? Why do we have dy dx? First of all, differentiation or derivative is the algebraic method of finding the slope of a function. Now, we use the graphical method and obtain the slope of this function, and this is equal to 1. Now, if we should use the algebraic method to find the slope of this function, we are still going to have 1, because we know that the derivative of this function, which is dy dx, must be equal to 1 if we should differentiate this using any method. But let's also go further to explain more about this derivative. Okay, now remember this is a straight line, and don't forget a line is infinitesimal. This line goes to infinity because if y is equal to x, both of them keeps increasing. So we have y equal to x. Now, we have seen that as x increases, y also increase. So let's add the increase in y to y and also add the increase in x to x. Why? Because if x increase, y also increase. So if we add the increase in y here, we have y plus the increase in y. And also, if we should add the increase in x here, we have x plus the increase in x. Now that we have add the increase in y to y and also add the increase in x to x, now let's try to find the slope. Remember, we are finding the slope of this function. We are using the algebraic method to find the slope of this function. And we already know in mind that the slope of the function is always in this form, change in y over change in x. So we are going to express this in terms of the slope. So the first thing we are going to do there is to take y to this side. So we have the increase in y equal to x plus the increase in x minus y. But don't forget, y is equal to x, so we can put x in place of y. So we have the increase in y equal to x plus the increase in x minus x. So if that is true, x will cancel x, so we have the increase in y equal to the increase in x. But don't forget, what we are looking for is the slope, and we said the slope is the increase in y divided by the increase in x. So let's divide both sides by the increase in x so that we have increase in x here, and this is also increase in x, and this will be equal to 1. This will be equal to 1. So what we have here is the increase in y over the increase in x equals 1. So we have seen that using the algebraic method, we also have 1 for the slope. And using the graphical method, we know also, we also have 1. Now, where did dy dx comes in? Let's continue. So I'm going to be cleaning this graph. If we need it, I will draw it again. We need the graph. I will also still sketch the graph. Now, we want to know where dy dx comes in. We have seen that from the graph, increase in x gets smaller and smaller and smaller and tends to 0. Increase in x goes smaller and smaller to 0. So we have change in y over change in x, which is the slope. Change in y over change in x, which gives us the slope, and this is equal to 1. Now, if we should take the limit as the increase in x approaches 0, now why are we taking the limit as the increase in x approaches 0? We have seen that from the function y equal to x, for us to have an increase in y, x must increase first. So it means that any evaluation we are doing for x, not y, because the input for x gives us the output for y. So we need x first before y. So if we take the limit as the increase in x approaches 0, of this slope, which is change in y over change in x. If we should take the limit as the increase in x approaches zero, because we have seen that from the graph, the increase in x tends to zero of this slope, there we have dy dx, which is the derivative of that function. And in this case, this is equal to 1. So that's what differentiation is. Differentiation, the algebraic method of finding the slope of the function. Okay, let's move on. Suppose we have this again. We have this, and this is the y-axis and the x-axis. Now, what if we have a curve of this nature? What if we have a curve of this nature? How can we find the slope of this curve? How can we find the slope of this curve? If you see, when we have a straight line, then when we have a straight line, we just take the increase in y divide by the increase in x, and we obtain the slope. But in this case, how are we going to take the increase in x, the increase in y, and the increase in x? It will not work. So we can just find the tangent, draw a line that will make a tangent to this curve, then we evaluate. But let's forget about that one. Let's still use the idea of differentiation here. Since we know this is a curve now, we want to find the slope of this curve, and we see that we cannot take the increase in y and divide it by the increase in s. Why? Because this is a curve. Then we can use the derivative method, and we see that suppose this curve was a function. Let's say this curve was a function f of x equal to, assuming x squared, and we want to find the slope of this function. We can say, okay, y is equal to x squared. And we see that if x increases, y will also increase. But x and y will not be equal. Why? Because x is carrying square here. Let's assume if x is 2, we are going to have x equal to 2 and y will be 4. So you see that a corresponding increase in x also gives us a corresponding increase in y, but they are not of equal values, so we cannot use the slope of a straight line. So what we are going to be using here now is, since we know this is a curve, let's just find the increase in x and also the increase in y. And we know that if we should add the increase in y here, we are going to have y plus the increase in y, and this is equal to x plus the increase in x. But this, we are going to square it because we have square here. Open this bracket, you have, don't forget, just expand this bracket. You are going to have x squared plus 2x change in x plus change in x squared. This is what you are going to have if you expand this bracket. Just expand it, just x plus change in x into x plus change in x, and you are going to have this. So now that we have seen that y plus increase in y is equal to x squared plus 2x change in x plus change in x squared, we can, the same thing, remember what we are looking for is the slope. And what is the slope? Increase in y over increase in x. That is the slope we are looking for. So what we are going to do here now, assuming we want to make the slope the subject of formula, we have to move y to this side. We have to move y to this side so that we have increase in y. So what we are going to have here is, first of all, we have y plus increase in y equal to x squared plus 2x increase in x plus increase in x squared. So let's move y to this side. We have increase in y equal to x squared plus 2x increase in x plus increase in x square. And of course, we have to, if y comes to this side, we have minus. So we have minus y here. But don't forget, what is y? Y is equal to x square. So what we have here is increase in y equal to x square plus 2x increase in x plus increase in x square minus x square. So x square, we cancel x square. So we have increase in y equal to 2x increase in x plus increase in x square. And the next thing we are going to do, since we are looking for the slope, we have to divide both sides by increase in x. So if we divide both sides by increase in x, this is what we have. Increase in x. We divide each term by increase in x. So increase in x, we cancel out, and we have 2 increase in x here. So if 1 take away 1, we have increase in y over increase in x equal to 2x plus increase in x. Now, we are not done yet. Don't forget, for us to find dy dx, we have to take the limit as increase in x approaches 0. So if we should take the limit, let's take the limit. Remember, to get rid of this increase in x here, to get rid of this increase in x, let's take the limit. Taking the limit as increase in x approaches 0. Because we have seen from that curve, if we are to find the slope, the increase in x will tend to get closer to 0. So if we should take the limit as the increase in x goes to 0 of the slope, which is increase in y over increase in x, and this gives us the derivative, which is dy over the x, and this must be equal to 2x, my chalk, this must be equal to 2x plus increase in x. Now, in place of increase in x, we are going to substitute 0. Anywhere we see increase in x, we put 0. So we have plus 0 here. So what we have here as dy dx, dy dx is equal to 2x plus 0, and this is equal to 2x. So therefore, the derivative dy dx, which is the algebraic method of finding the slope, is equal to 2x. So that's how you find the slope of a function using the algebraic method. Please take note, the slope of the function using the algebraic method is dy dx. So this is what we have. Dy dx is now equal to 2x, which is the algebraic method of finding the slope of a function. So please, I want you to know that all this explanation or all this we have just did is the derivative of a function from the first principle. Please take note. This method we just use now, this method we just use, finding the corresponding increase in x, the corresponding increase in y when x increases, is the derivative of a function from the first principle. So please check out the second video for the derivative of a function from the general method rather. So we can actually find the slope of any given function using general method, and the general method is much more easier than this first principle. So please, if you enjoy this video, please like this video and also share it to your friends, and comment, do well to comment, and if you are new, please subscribe. I'm begging, please subscribe. Please, I'm begging, subscribe. So that is all I have for you for today. See you in the next lesson.